Hey guys, Mr. Milton here. Today we are looking at the angle addition postulate. At the end of this video, you should be able to use the angle addition postulate to find missing angle measures. First of all, when we talk about an angle, we use the symbol, it's almost like an L or alligator, I guess. I don't know. An angle. Okay, and it's formed by two rays with the same endpoint, and the endpoint is called the vertex. Name the rays that form the angle. In this diagram here, remember the endpoint is B. The ray goes this way, so we call it ray BT. Again, reminder that anytime we name a ray, the arrow goes to the right, no matter how the direction of the ray is. And we have ray BQ. Those are the two rays that make up the angle. And that vertex is the endpoint. So the vertex should always be the endpoint of the rays, which is B. Okay, now there are a bunch of different ways we can name this angle. The most common, typically, if you want to, is just call it angle B. I'll tell you some instances where we would not want to name it that. The other way is just how we would name it by drawing it without picking up our pencil. Okay, so we could call it angle TBQ. We could call it angle QBT. Okay, and that's, again, how we would draw the angle. If we were asked to draw the angle without picking up our pencil, we'd go from this way to this way, TBQ, or this way to this way, QBP. Okay. And then finally, you'll notice that there is a number inside that angle, and that number is not there on accident. It's there to identify it. We can call this angle 1. Okay. And so there might be problems where there's a bunch of different angles there, and we'll mark those angles so that we can quickly identify it and say, hey, that's angle 1, that's angle 3, that's angle 4, and everybody knows what's happening. Okay, so the whole point of being able to name these is that we can distinguish between one angle and the other pretty easily. Also, notice that when naming the angles that the vertex is always the middle name, or the middle letter named, always. Name angle 1 in another way. Couple different ways that we can name angle 1. Angle 1, I'm going to name this angle ABC. Okay, and I'm naming it ABC because it goes from A to B to C, ABC. Okay, name another way to name angle 2. I'll call it DBC, angle DBC. Again, I don't want to just call it DBC. Remember that if we just use 3 letters without the angle symbol, then that would be a plane, and that's not what we're trying to do. So DBC, okay? Says name angle S in another way. You know what I think it was supposed to be? It's supposed to be B. Cool. So name angle B in another way, and the way that, and this is the reason why we wouldn't want to really name it angle B. It's that one of the options that we're given is that we can name an angle based off of its vertex. And when we look at the vertex of angle 1, it's B. When we look at the vertex of angle 2, it's B. When we look at the angle or the vertex of angle, I'll say angle B, like what are they talking about? Are they talking about ABD? Probably. Okay. The vertex would be B. Okay. And so when we name these angles, especially the ones that have the same vertex, we're not going to want to continue to use the same way. Like, again, names are, the whole point of names is to be able to distinguish between one thing and the next. And so we're not going to want to use a name that we can't tell, like the difference between, right? It would be like going to a family reunion and calling everybody by their last name if they have the same last name. It'd be like, well, who are you talking to? Stop doing that. We want to make sure that we are distinguishing between, or making clear what we are referring to. Okay, so that's why, like I said, we might be given angle 1 or angle 2, or angle B would be not helpful in this situation, because if I say, hey, look how small angle B is, you'd be like, well, wait a second, ABD is a pretty big angle. Okay, or are you talking about 1 or are you talking about 2? Okay, and if you have to ask, well, which one are you talking about, it's not a helpful way to name it. So it says how many angles are in the figure. We can see 1, 2, 3 angles in this figure. All right, let's classify. Should be a review because these are just terms that hopefully you're familiar with. It says an acute angle. Okay, we have acute, we have, well, we'll talk about it. Acute angle, remember, is any angle that's less than 90 degrees. Okay, anything less than 90 degrees is acute. Anything that is 90 degrees, equal to 90 degrees, is a right angle. An obtuse angle is greater than 90 degrees. And do this, x is less than, x is equal to, okay. And then I'm going to erase that because I want to redo how I wrote that. Okay. An obtuse angle is greater than 90 degrees, but then at the same time, it's less than 180 degrees. Okay, because a straight angle is when x is 180 degrees. You'll notice that there's no zero, like anything zero would probably be 180 degrees, be a straight line, but there's not a zero. Angle addition postulate. We talked about the segment addition postulate last time, so this shouldn't be too much different. The only difference really is that we're talking about angles instead of segments here. So it says if B is in the interior of AOC, and it's just describing this specific situation, then we can use the angle addition postulate, which is part angle AOB plus angle BOC equals the whole thing, angle AOC. Again, part plus part equals whole. That's the angle addition postulate, very similar to the segment addition postulate. Okay, the second scenario is basically the same thing, except we're saying, hey, this even works with a straight angle. Okay, again, we're just going to say, hey, if it's a straight angle, again, angle AOB plus angle BOC equals the whole thing, angle AOC. Same thing, just saying, hey, when it's a straight angle, it works too. In both cases, part plus part equals whole. So here we go. Let's look at some examples. Use the figures below to answer the questions that follow. Find the measure of angle CBA. CBA. Okay, again, don't just look at the diagram. See what other information is there. Here, they give us, the given information is that DBC is 24. And ABD, the whole thing is 83. Different color. Scoot up. All right, so got that down. All right, and now it's asking us to find CBA. So CBA is this piece. We know that this plus this should be, or part plus part should equal whole. So we can really set up the equation and say 24 plus, let's call it X, equals DBA 83. Subtract 24 from both sides, and that should give us 59. So X is 59, and we're putting X in its place here. So CBA 59. Next problem asks us to find the value of X. And it might look from the onset like, hey, they don't give us enough information, but remember that they kind of do based off of us knowing that this is a line. Okay, we see here that this is a line, it's a straight angle, right? And so since it's a straight angle, this should be 180 degrees. And so we can say part RQS plus part TQS equals whole. 4x plus 13 plus 3x minus 1 equals 180. And so from there we can solve. So that gives us 7x plus 12 equals 180. And that gives us 7x equals 168. And that is 2, 4. We find out that x is 24. continuing with this question, it says classify RQS, and that goes back to our, is it acute, is it right, is it obtuse, or is it a straight angle? Okay, so RQS is here, and we're not going to classify it on its visuals. Okay, so visually we'd say, hey, this is an obtuse angle. What we're going to make sure that we do is that we plug the values in and see what our actual value comes out to be. So RQS, plug in 24 times 4, 80, 96, plus 13 should give us 109. So RQS is 109. Mathematically, we'd have to say that this is 71. Let's hope that it comes out to be that way. 24 times 3 is 72. You have minus 1, 71. Great. So classify. So we did not classify. These are not classifications. These are just values so that we can classify. So our classification, because it's greater than 90 and less than 180, this is obtuse. And because this is less than 90, this is acute. Okay, that did not make that C any better. I tried. Okay, so looking at this final problem, it says find the measure of each angle. You'll notice that we're given these arcs, and these arcs are the same thing for us as a dash and a segment, except it concerns lines, or sorry, not lines, angles. So these arcs are telling us that, hey, these two angles are congruent. Okay, so when they tell us that AOB is 2x, it's also telling us that COD is 2x. Okay, and so now we're going to add that with the information that they give us down here, that angle BOC is 12x plus 5. So this is 12x plus 5. And now that AOD is 105 degrees. So now I can use my angle addition postulate, which says that 12x plus 5 plus the 2 x's should equal the whole thing, which they told us is 105. So we add all this together, we get 16x plus 5 equals 105. 16x equals 100. And then x should be 100 divided by 16, which I'm going to use a calculator here. 100 divided by 16. And that gives me 6.25. So I find that x is 6.25. Okay. So now with that, I can say angle BOC is what happens when I plug that in. So 12 times 6.25, 75 plus 5. And that should give me 80. So BOC is 80 degrees. For BOD, it'll be BOD, I'm going to plug that in. That's going to be 14x plus 5. So 14 times 6.25 plus 5 gives me 92.5. And for AOC, that should also be 92.5. Just did the math there. Okay. Okay, again, notice that the markings on the angles, those represent congruent angles. Congruent, so we write it that way, but for the most part, we'll write it like the equal sign with the tilde over. All right, so that's that.